Welcome to another PCB and DIY project video on my channel. And I wanted to design myself a PCB where I can test LEDs and not so much test them, but like test them what is the best series resistor for them in order to drive them a certain brightness. And I am using these LEDs mostly when I'm working on my model trains. So sometimes I use normal LEDs like this. So I wanted to have the ZIF socket so I can just easily put them in and test them, as in just like how you would do them in a component tester. But I'm also using various SMD LEDs. So the idea was that I would create these footprints where I can place the LEDs and I can play around with the brightness and just to find the correct brightness that I want for a particular project. And sometimes I use multiple LEDs in series, so I wanted to have multiple pads so I can just stack them up on the pads and that are connected in series, so I can figure out what's the best resistor value for let's say 3, 4, 5 or 6 LEDs in the series. And I think this is the first PCB where I conceptually failed in my idea. Not that the idea was wrong, but it's the execution and how that is going to work was wrong. And I'm going to talk about that. This video is sponsored by PCBWay. PCBWay is a manufacturer of all type of PCBs, offered PCB prototyping services, but you can also order fully assembled PCBs as well. If you need flexible PCBs, you are covered too. Besides PCBs, they also offer CNC machine services, 3D printing as well, with a huge selection of materials and printing technology. I am an absolute beginner when it comes to electronics and PCB design, and all my projects are about designing special boards where I use development boards and maybe some passive components. But I have to tell you that these boards are already light years from the breadboard projects in terms of looks and reliable operation. And these PCBs really turn my prototype projects to live projects that I will use for the years to come. If you like my projects, I always link a link to my PCB that you can order directly from PCBWay. Or if you want to buy a different board or service from them, please use my referral code, which you will also find in the video description. And well, this is how the PCB looks like. Focus, please. Yes. This ring light is really making this camera difficult to focus. Yes, if I bring it closer, then it's better. So as you can see, there are two potentiometers on the top. One is 1K and the other one is 5K. I mean, these are the typical values that I work with, and they are connected in series. So you can choose which one you want to use, and you have the ZIF socket. You have two test points, TP1 and TP2. Ooh, where is my white balance? Wow, spooky. And then you see that you have, well, I have a couple of footprints. So 50, 50, 35, 28, 12, 6, 0, 8, 0, 5, 0, 6, 0, 3. And as you can see, these are connected in series. And I have a couple of jumpers up here, so I could select whether I want to measure just one LED or two, or series 3 in series, 4 in series, or if I remove all the jumpers, then it would be 6 in series. And I've also created a footprint for a 50-50 where the 3 LEDs are connected in series. And if I remove this jumper, then I could use these two test points to test an actual resistor. So let's say I dial in the resistor using these two pots. I use TP1 and TP2 to measure the resistance with a multimeter. And then I've removed this jumper and I can use these points to actually test with a real resistor, which is one of the close values which is available. So on the final design, you can see that I added all these jumpers. There is a jumper for here, the power comes on through here, and I put some, basically just one jumper wire here, not jumper wire, male headers. So you can just take the resistor and push it against just to test it. And I have the two pots, and I have the ZIF socket. And the idea was that I will include this in my field PC, in that big bag that I said, and I said that I'm going to use this old Ryden power supply, which I'm not really using anymore because I bought one of the bigger ones which has the keypad. So this has been sitting in my desk for a long time. Mostly because it's small and it doesn't have keypad, but on the field PC case, I think the fact that it's smaller is actually going to be an advantage. So let me show you how it works. So this is now connected, and I mean, on my trains, my DCC trains, the DCC voltage is 18 volts, so I can dial in the voltage here to, let's say, 18 volts, but I'm just going to use some lower voltage for now. And let me prop this up so it becomes a little bit more visible. Yeah, so if I turn this on, nothing happens, but if I put the LED on, then you can see that the LED is lit. And I can just, play around with the resistors just to control the brightness. And of course, there is nothing really magic in this whole circuitry. Of course, I should remember what's the typical forward current of this, the LED that I'm using, and I can check the current here. So obviously, if I want maximum brightness, I will dial in until I reach the current. To be honest, I have no idea what's the current for this high brightness green LED, but let's say it's 13 amps, then I know that this is the sort of the resistor value I need, so I can turn off the power supply. I can measure the resistance between the two test points, so I know what is, roughly the resistor I need to use for this voltage in order to get this brightness. And of course, I can always double check that the LED is not getting warm. I mean, that's usually my method of making sure that I'm not using too much current. And so far this is working fine, but then, obviously I want to use it with SMD LEDs, and this is where the failure comes. So let me just bring you a little bit closer. So the problem comes when I start testing SMD LEDs, and the issue is that these pads that are, coming from PCBWay, as you can see, I think probably as part of the manufacturing, there is a small amount of solder on these pads, which means that those pads are probably not perfectly flat. And for that reason, these LEDs don't really sit on these pads correctly. And I just can't get them work reliably. So this one is working now. Oops, sorry. Let me just dial the voltage back. So now this one works because that's a small LED. It only has two legs, well, two connections. So, well, yeah, you won't be able to see that. So it's easy to get them flat. But for example, this 5051, which, I mean, I really like this because this actually has 3 different diodes on the die. And then if you would see this has actually 6 terminals as you see on the pad. But it's almost impossible to get all these 6 pads to sit on this footprint correctly. I mean, I can get maybe one of the LEDs to show. And yeah, and I have to hold it with my tweezer, and then, I mean, I can see the camera doesn't really give it, provide a really good representation, but it's only one of the LEDs lit at any point. So yeah, I can't really use it with a 5050. This one is a little bit better, this small one, because again, I can easily get this one flat, and this might not be the correct pad size for this particular part, but I mean, it has 2 terminals, so I can see any pad which sort of fits this LED. Maybe I have the wrong way around. Actually, I think I do. Yeah. So now this one working. So that was the idea. And yeah, it does not really work. And of course, I tried using, you see the wick here, so I was trying to use the wick to clean up these solder pads, and then I also try to apply a little bit of solder, but I really only have my soldering iron, and it is really difficult to control how much solder you can get on these pads. I mean, for these pads which only have 2 terminals, it's easy because I can just create a dome, and it is much more likely that these LEDs will sit on the dome as opposed to, well, because the only two terminals would much easier, you know, sit on the dome. But for this 5050, which has so many terminals, maybe I can get this one. Yeah, so you can see the 6 terminals. So I think those would be almost impossible to sit. And of course, I don't want to solder them in place, because the whole idea is that maybe I would want to use these pads or these pads or these pads. What I could do is I can break these up and I put some additional jumpers here, so I select which sort of line I want to use for testing. And probably for the 5050, this is the only type of LED that I would ever use. But it just doesn't make it so versatile and usable. But I think for the single LEDs, I can still test them. And of course, if I move the jumper for the next position, then, well, it's not, oops, then it's not going to work, because I need a second LED in the second position as well, which I don't have at the moment. And this guy is probably moved as well. But again, since the connections are so unpredictable and hard, I think it would be really difficult to get like multiple of these working at the same time, because if this doesn't work, you don't know whether it's not, you know, the LEDs don't light up because this one is not connected correctly, or this one or that one or that one. So yeah, so unfortunately, I think this is a bit of a fail. I think I will still be able to use that, and especially for normal, you know, 5mm or 3mm resistors, I can use the ZIF socket, and also the pots work. And if I want to, you know, test a single one, then again, it works, and I can, especially for these ones, I can just sort of like manhandle them and, you know, like really gently get the positions where both of the terminals sit on this solder blob. But yeah, it's not going to be that easy thing that I have imagined in my mind. So unfortunately, this is not the best one, the best of my PCBs. But regardless, I'm happy that it worked out this way, and I managed to get this one drawn up in the CAD software. So I think that will be all. I'm not sure if I'm going to put this on the shared project, just because I don't think it lives up to the expectations that well, I had in mind when I designed it. But I think that will be all for today. Thanks for watching, and hopefully see you next video.